So here we're looking at scale drawings, basic scale drawings, and what we're going to look at doing is we're going to think about the purpose of scale drawings, why we need to use them, and then we're going to look at the actual drawing part of scale drawings. So we kind of said there we use our scale drawings to either make something bigger or make something smaller so that we can see it compared to its original. And the important part that helps us determine how much we've done it is the scale. And the drawing bit is just the picture part, but hopefully that's self-explanatory. So first thing we need to do is we need to get our head around the purposes of needing to enlarge or reduce an image. So if we have a look at this, all right, we've got a tiny little rectangle there, there's some lines on it. We can see a little bit of detail, but not very much. Okay, there's something there, but you know, we could take a guess. As soon as we want to start adding any more detail to that, though, if we were to try and write some sizes on or some dimensions or try and measure things, it becomes very difficult to do to any kind of degree of accuracy. Okay, so what we might do is we might zoom in on it, we might make it a bit bigger. And now we can see pretty clearly what the pattern looks like, we can see what was going on, we can see what happens if we need to add sizes or dimensions or little notations to the side of it, then we can do that and it won't look overly cluttered. Okay, and a prime example when we do that would be in electronics. Okay, if you think about circuit boards and circuitry, right, all the little wires and connectors going about, they're not actually very big to see, but you need to be able to see it when you're manufacturing them because you need to know which bits to join up. Okay, if you were to do it the actual size, you would never be able to see where the things went. Okay, so in that case, we would have to zoom in on what was there. Thinking about going the other way, we start with something very big. And so all of a sudden it's taken over my screen and I've got essentially just a green rectangle with a black cross through it. And if we zoom out a little bit, we've still got a green screen with a black cross and there's a little bar, a horizontal bar across the top. Zoom out again, we find that we've still got the cross, we've got a horizontal bar, but now we've got two vertical bars. There's one more obviously at the right and there is one slightly at the left. We can kind of see that. If we zoom out again, we can see that we're starting to see more of the picture now. We can almost see the outline of it totally. Again, the clue for that is that I can now start to see the blue background on the slides. And if we zoom out once more, we can see the full image, right? I can see right the way around the edge of that. And I can see that actually it's not just a green rectangle with a cross in it, it even has this kind of rectangular border around it as well, which wasn't apparent right at the very start. And so if we had just made our assumption based on what we saw, then it wouldn't be giving us the complete picture. Okay, so we've reduced that down and actually we can see it all. Okay, so a good reason that we would do that, and kind of the historical one, the one we always think about is when we look at maps. Okay, it's not practical or reasonable or sane to draw a map the size that things actually are. Okay, otherwise if you wanted to have your roadmap of Great Britain, it would need to be the size of Great Britain, and that's just not feasible. All right, so we scale it down to what used to be kind of car sized, but no one has a road map in the car anymore. Everyone uses sat-nav and their phones and whatever, but the same principle applies, right? You still use the scale on the movable map on whatever screen it is you tend to take with you. Okay, so it's about making it feasible, but it's about making it mean something. Okay, it's about giving you the detail and the information that you are requiring there and then. Okay, if we had just left the big rectangle the way it was, we would have missed out a whole load of stuff that was in it that we didn't even know was in it, right? So that's one of the reasons that we need to make sure that we're careful, but we can do the scale drawings. So think a little bit then about the scale part. So the scale bit is the bit that tells us how much of a change the shapes had, okay, when we compare the image that we've got in front of us to what it should be in real life. Okay, it's got two parts, and it can be written in two different ways, depending on where it is that you're looking and what context you're thinking about. One of those ways you can be a little bit more lazy with, so there is a kind of third option, if you like, that I'll show you, but it's just a lazy version of one, so we don't count that as a different option. There's just two options. So, for example, we could write it as 1 centimetre equals 5 metres, or we could write it with a colon, we could write it as a ratio where it's 1 centimetre to 5 metres. Okay, it's a comparison that we're making. Our slightly lazier way could be if we wanted to go with that one, but it doesn't necessarily always work out for the lazy person. because when we're doing that there, what I've done is I've ditched my units. Okay, so in the first two, I had to write centimetres and I wrote metres. Here, I've just written the number parts. But when we're doing that, we're not including any units. The assumption is that they both are the same. So they both have to be the same thing, and so I've changed my 5 metres into 500 centimetres. Okay, so depending on how big a thing you're working with, by the time you've written in all of your zeros, it might not be worth it, right? It might even quicker just to write meters, kilometers, miles, whatever. Okay. Crucially though, they all still follow the same pattern. Things on the left is what is going to be in our drawing or image, the thing that you should have in front of you, and on the right hand side is what it actually is in real life. Okay, either really big, really small, whatever. Okay, so that's the conversion. So we've got drawing to actual. So taking a wee example. Right, we've got a little car, in no way comes from the stock images, but it's drawn with a scale of 1 centimetre, would be 2 metres in real life. Okay, so when we're doing this, we need to first know how big it is in our drawing. So we're going to whip out our ruler, boom, which I've also helpfully numbered, and we need to work out the length of the car. So from back to front, it just happens to be 2 centimetres there, which was just the exact same size snippet of ruler I had. All these things are so coincidental. And so here, our car's 2 centimetres. So if 1 centimetre is worth 2 metres, we've got 2 of them. And so in this instance, using the scale, car must actually be 4 metres long. Okay, another scale that we are going to need to have is we're going to need to be able to create a scale drawing. Okay, so here we've got a real life situation, some kind of ship sailing into a cliff face. It doesn't really matter, right? There's a picture. We're going to try and do a scale drawing of it. So we want to use a scale of 1 centimetre to 40 metres for this picture here. So first thing we need to do is we're going to need to work out how long we actually have to draw the line. So in the picture there it's 160 metres. So we're going to need to do a bit of conversion. Use my scale. Every centimetre in my drawing counts for 40 metres in real life. So I want to work out how many centimetres do I need to draw to get to 160 metres in real life. And so the good thing about treating them as ratios is we can just compare them. So how have I gone from 40 to 60? What have I multiplied it by? I have to have multiplied it by 4. Okay, because I've done it to that side, I have to do the exact same to the other. Okay, so my missing number there with the question mark should be 4. 4 centimetres is what I'm looking for. If we don't like it that way, we can think about going the other way. Okay, we could start at 160 and go back to 40. How many 40s go into 160? How many do we divide it by? We divide it by 4. Okay, we would have to do the same thing on the other side. What divided by 4 is 1? Again, it's just 4. So the actual length we're going to draw here is 4. So we've done the first bit of working out. We need to know that before we can start. So, start my drawing. Again, I'm going to whip out my ruler, and I'm going to draw my line 4 centimetres. Okay, hopefully that's a scale that we've managed, but you know, who am I to judge? Okay, 0 to 4. You go 1 to 5, 2 to 6. I don't really care. Just draw it so it's 4 centimetres long. Right, and then get your ruler out of the way. It'll only bother you. Next thing we need to do is look at the picture. Other information it gives me is the angle. Okay, and whoever it is that's standing on the front of this ship here has clearly been able to work out that there is a 30-degree angle between the ship and the top of the cliff face. Okay, now the good thing about our scale drawings is it doesn't actually matter what the angles are. They're going to stay the same in the drawing. So I'm going to need my protractor. So I get my protractor out and I'm going to measure 30 degrees round from my line. So I've lined up my protractor on the line that I've just drawn, and I want to head up in the 30 degree section. So I've made my way mark, I've drawn my line, I'm going to get rid of my protractor. Okay, now whenever we're doing this first line, it can start off by being a little bit longer than we need it to. Okay, but because I've already measured the line on the bottom, I know that that's where my cliff face goes, and so I can see that I've gone too far with my line. Right, so we can reduce it, we can rub it out, we can bring it back to the actual bit that we're interested in, but we can worry about that later. So whenever we're doing them, don't worry about going too far. It's always better to have too much line than not enough line. So once we've done our diagram, we need to start labeling it. Okay, so we've got our angle there of 30 degrees, and I've got the length that I've drawn of 4 centimetres. Okay, and if we feel overly excited about it, we can even draw a wee pirate ship in as well. Okay, so there is our wee scale drawing. What we might want to do is we might also want to use the scale drawing to help us work stuff out. Okay, so we might have that, but then want more information from it. So just, pinching an example that we may have seen before. Oh, look, we've got a ship heading towards a cliff face. So here's a scale drawing that we've just drawn. Okay, it's 4 centimeters long. It's got an angle of 30 degrees. What we might want to know is, what is that height? Okay, perfectly reasonable question, and we can use our drawing to help us. So again, we're going to need our ruler, and we're going to have to bring it over to help us. So again, we're going to count from the bottom right up to the top, and depending on how good your PowerPoint skills are, you can line up the lines maybe a little bit better than I can. You might get more accurate measurement. 3 centimeters here is the length of the line that we're looking for, so that will do. Okay, it'll ask you how accurate you want to be. You should try and be as accurate as you think is necessary. All right, so here we could have gone for 3.1. We're going to go for 3 just to keep it easy. So we're still using our scale of 1 centimeter to 40 meters. So we kept that there just to remind us. So here the height measures 3 centimeters. So our scale means that 3 centimeters is worth how much? Well, for every 1 centimeter, I'm going to go along, or going to go up 40 meters. And so my actual height is going to be 3 lots of 40, which in this instance has to be 120 meters.